Hello everybody, today we are going to be talking about converting between units. There is a fancy definition or a fancy term for converting between units. It's called dimensional analysis. I'm going to get into that a little bit, but really what dimensional analysis is converting between units, getting from point A to point B or unit X to unit Y through a series of multiplication and division steps. Now, in your homework, you had to complete 5 conversion problems just to get you thinking about how you already know how to convert between a lot of units. This is just going to be a more scientific approach to doing what you already know how to do. So, let's get started. Conversion factors. Now, a conversion factor is an equality that is expressed as a fraction. So this is a ratio that we use to convert from one unit to the other. So for example, 60 seconds equals 1 minute. We could write that as 60 seconds over a minute, or we could write that as 1 minute over 60 seconds. These are ratios or equalities, which hopefully you've learned about in math already. This is just saying, hey, these two things are the same. They have different units, but they are the same amount of stuff. Now, let's do some conversions that you already know how to do. Go ahead, let's convert 1,145 seconds into minutes. Well, if you are at home, you might think, okay, well, I know that there are 60 seconds in 1 minute, so I should be able to take 1,145 and just divide by 60, and that will tell me how many minutes I have. So if we do that, we'll take 1145 divided by 60, and we should get 19.08 minutes. Pretty straightforward. You guys have been converting between time units forever. Now if we go the other way, 19.08 minutes is how many seconds? Well, we would take 19.08, we would, again, knowing that there are 60 seconds in 1 minute, we would have to multiply by 60. And when we do that, we should get 1,145 seconds. So these two things, these two quantities are the same. They are just expressed in different units. But you see, all we had to do was divide and multiply. It wasn't really much more difficult than that. I want you to come into this with an open mind. We're really just multiplying and dividing, which you've been able to do for years. Now let's look at the method that we're going to use. So I want you to make this really big and really bold in your notes. This is how we are going to convert between units. For this, we're going to use that worksheet that I just talked about, the Intro to Unit Conversions practice that you worked on last week. The first question is this one right here. If you run 7 laps on a standard track size, how many miles did you run? But we are going to answer this problem using our new method. So, step 1 of our method says to start with the measured or given value and write it on the left side of your page. So the measured value is 7 laps. So I'm going to write 7 laps on the left side of this problem. Then it says to write the unit that I want to get to on the right side of the page. I want to get to miles, so I'm going to write MI on the right side. Step 2. Next to my original value, write an empty fraction. So like I said, we're going to do steps of multiplication and division. So I put a multiplication sign, and then I have my divisor, my empty fraction. I'm going to put a number on the top, and I'm going to put a number on the bottom. Just multiplying and dividing. So there it is for you if you want to write it down. Dimensional analysis or unit conversion is a series of multiplication and division steps. So I'm going to put something here to multiply by and something to divide by. Remember that you can pause this video at any time so that you have time to write all this stuff down. Or write down whatever it is you need to write down. So I'm just going to copy over what I just had. 7 laps. My empty fraction. It's going to be some number of miles. Step 3 here says to, on the bottom of my empty fraction, write the units that I started with. We want this unit to cancel. So the unit that I started with is laps. So I'm going to change colors actually. So I'm going to write So I'm going to write laps on the bottom. This is my new step 3. Laps is on the bottom. I want this unit to cancel out. So how does putting it on the bottom help it to cancel out? Let's think about it. What is x times 1 over x? X times 1 over x. This is just like in algebra. You've done this a million times. X times 1 is x. X divided by x equals 1. So by those x's being on opposite sides of a dividing line, I end up with what's left from the numerator. This works if I do x times y over x, right? X times y over x, I should get y. So with that same thought in mind, I want laps on the top and laps on the bottom of these fractions here so that they cancel out with each other. Then on the top of my fraction, I'm writing the units that I want to get to. I want to get to miles. All right, so that's like with this one right here. The x is canceled out, and I'm going to end up with y, the units that I want to end in. So these laps are going to cancel out. I'm going to be left with miles. Then I need to fill in my conversion factors, and it says make sure to match units. Oh, well, I guess I need to know what my conversion factor is. You guys have taken PE classes. You know how big a track is. Usually, there are 4 laps in every 1 mile on a standard high school track size, or Olympic for that matter. So we need to, this is our conversion factor. We need to put this information into the fraction. Now when it says make sure to match units, what I mean by that is we can't put the 4 next to miles. There aren't 4 miles in 1 lap. There are 4 laps in 1 mile. So let's erase that. We need to keep the laps with the laps and the miles with the miles. So the 1 is next to miles, and there are 4 laps in every 1 mile. That's how I fill in my conversion factors. So I've just copied everything from the last slide over to this slide. Now we're on step 6. Step 6 says to multiply everything in the numerator and then divide by everything in the denominator. So if I multiply across the top, the numerator, 7 times 1 is 7. Okay, so then I'll have 7 and divide that by everything that's in the denominator. So 7 divided by 4. Now this is a problem that you were probably able to figure out the answer to without going through this fancy unit conversion thing. You should have just been able to count. Well, if I did 7 laps, that's 1 mile plus 3 extra laps. So I should get 1 3/4 or 1.75 miles. So do you see how you already knew how to do these conversions? You are just now using a new method. You're probably asking yourself, why do we need to do this new method? And I know it seems challenging or too much, but we need to learn this method so that we can use it for the more complicated units. So this problem is pretty straightforward, but this is a method that we are going to use for the whole year. So it's better to learn the method with something that you already know how to do, just to prove to you that it works and so that you can get that practice down. So after we've multiplied and divided everything, we check that our units canceled appropriately. So let's see, laps is on the top and laps is on the bottom. So those both canceled out. The only thing I'm left with is miles, which is perfect because I ended up in miles. Then I need to round my answer for sig figs and include units. I already included units. Now let's talk about sig figs. So depending on when you watched this video, we may or may not have already talked about sig figs or significant figures. If we haven't talked about sig figs yet, that's okay. Just write down your answer, 1.75. We'll get to sig figs. If you have already learned about sig figs, then you should know that because I only have 1 sig fig in my 7 laps, I can only have 1 sig fig in my answer. So I actually have to round up 1.75 to 2 miles to keep the same number of significant figures. Conversion factors don't count towards significant figures, so this stuff in the middle here does not contribute towards the number of sig figs, but they both have 1 anyway. So And that's why sig figs is sort of weird, because in your head you're like, well, 7 laps is 1.75 miles. Why should I say that 7 laps equals 2? Remember, significant figures are about precision. 1 sig fig is simply not very precise. 2 sig figs, more precise. 3 sig figs, even more precise. So the more sig figs we have, the more precise we can be. But we're limited by the original measurement, or the original value of 7 laps. Last, check that our answer makes logical sense. It does. 1.75 is the number of miles in 7 laps. We already know that because we've ran a mile before for PE. We didn't change the size of the number. All we did was change the unit. That's pretty much the method for unit conversion. Let's go through another example problem just so you guys can get in the swing of things. So the second problem from that worksheet says, how tall are you in centimeters? So the first thing that I actually need to do is figure out how tall I am in feet and convert that to inches. So if you know how many inches you are, well, I'm 5'3". We're just going to use my height here. I'm 5'3". I know that with 5 feet, there's 12 inches in a foot. So I have 60 inches plus 3 inches, giving me a total height of 63 inches. So again, 12 inches in a foot. I already knew how to do that one. So 60 inches plus those extra 3 inches. Technically, there's an extra quarter on there. That quarter is very important to my overall height. Don't forget it. But you can leave it out for the sake of this example. So I am 63 inches tall. And I'm going to write that number according to number 1 over here. I'm going to write that number on the left side of my page. And then I'm going to write the unit that I want to get to on the right side. So I want to know, how tall are you in centimeters? So I want to convert from inches to centimeters. Next, I'm going to write my empty fraction. Remember, dimensional analysis is just steps of multiplication and division. Then on the bottom of my empty fraction, according to number 3, I'm going to write the units that I started with, which is inches. Remember that I want inches to cancel out. So now I just need to copy all this over onto the next slide, and we can keep going with our steps. So starting with step 4, on the top of my fraction, I'm writing the units that I'm going to. So in this case, I want to convert to centimeters. Remember, if I have x times y over x, let's make this a more obvious y. If I have x times y over x, the x's will cancel out with each other, and I'll be left with that unit from the top, y. So I want to be left with centimeters. Then I just need to fill in my conversion factor. I provided you with the conversion factor here. I said 1 inch equals 2.54 centimeters. Remember, we have to match the unit to the number. So since it says 1 inch equals 2.54 centimeters, that 1 has to be written next to inches, and the 2.54 has to be written next to centimeters. Then I multiply across the top and then divide by anything that's in the bottom. Luckily, my denominator is 1, so I can just ignore it. So all I have to do is take 63 and multiply it by 2.54, giving me an answer of 160.02 centimeters. So that's how tall I am in centimeters. Now I know if I ever need to like buy pants or something from the United Kingdom or from somewhere in Europe. Now we have to check that our units canceled appropriately. Well, inches are on opposite sides, so those canceled out. I'm left with centimeters, which is good. That's what I wanted to be. And then I need to round my answer for sig figs. My original answer has original number has 2 sig figs, so my answer can only have 2 sig figs. So my answer is 160 centimeters. Remembering, of course, that trailing zeros do not count towards significant figures because my decimal is absent. All right. And I included my units. The last step is step 8. Does this make logical sense? I think this makes logical sense, right? If we think of a meter stick, you know, I'm about 1.5 meter sticks tall. Each meter stick has 100 centimeters in it, so if I can picture in my head 1.5 meter sticks, then I think 160 centimeters makes sense for how tall I am. And that's dimensional analysis. You can go ahead and rewatch this section of the video as many times as you want to. Again, it's just a brief introduction, but I do want you to go through these next three or the last three problems from that worksheet and see if you can put your dimensional analysis skills to the test. So go ahead and pause the video and try to figure out how to get from one unit to the next using this new philosophy. Go ahead and pause it. All right, welcome back. We're going to go through a couple of these problems here. So let's get started. On the top one, it says, I'm traveling at 65 miles an hour. How long will the 230-mile drive to the Chiefs game be? This is a little bit of a tricky one to get started with, but hopefully you were able to work it out. The given information, or the information that you need to write on the left page first, is actually the 230 miles. That's my measured value. And I want to convert that. It says how long. I want to convert that into hours. So I'm going to go from miles to hours. Then I write my empty fraction and put the unit that I want to cancel out of on the bottom. I want to cancel out of miles, so I'm going to put miles on the bottom. And I'm going to put hours, the unit that I want to go to, on the top. Now the question is, what is my conversion factor? The conversion factor is going to be something that relates miles and hours together. And if you look, I gave that to you. I said that you were traveling at 65 miles per hour. If we rewrote this, it would be like saying 65 miles can be traveled in 1 hour. So this is our conversion factor. I have to put the 65 next to the miles, and I can go that far in 1 hour. That's how you fill in the conversion factor when you're using something like speed. Then I multiply across the top and divide by whatever is in the bottom. So I take that 230, multiply by 1, which is 230, and then I divide by 65. You should get 3.538 hours, or 3.5 hours approximately. Our last couple steps are making sure that our units canceled. Well, miles and miles are on opposite sides. I got hours, which is what I wanted to get, and I wrote it there, so I included my units. And I also need to check for sig figs. 230 has 2 sig figs, so my answer needs to have 2 sig figs, so I can round 3.538 to 3.5 hours. And that's the correct number of significant figures. Now, number 4. This one was a little bit of a gimme. It said, essentially, how many pasta dishes can I make with 1 gallon of milk if I have 1 cup of milk for every time I make the recipe. So if there are, I Googled this, I said, how many cups are in a gallon? This is something you might not know off the top of your head. Well, there are 16 cups in 1 gallon. And so since I said that I had 1 cup of milk, or I needed 1 cup of milk for each recipe, it makes sense that you would automatically just say, hey, I can make this dish 16 times. But let's just go ahead and prove it, right? If I have 1 cup, I can convert that. So cup to gallons. I want to end up in gallons over here. So there's 16 cups in every 1 gallon. So every time I need to make this recipe, I need 1/16 of a gallon. So I could make it 16 times, is how many times I could make that pasta dish. Then the last one. Let's see, today is September 2nd. How many minutes are there until September 5th? This one was a little bit longer. Had you do a couple of different steps. So I want to know how many minutes are there. That's what I want to end up in, minutes. But what is my measured value? What is my original value? Well, if you think about it, it's days. I told you where we started and where we ended. So you needed to figure out that we started in days. Now, from this point, you might have decided just to convert straight from days into minutes. But I don't know off the top of my head how many minutes there are in a day. I do, however, know how many hours there are in a day. So I can do a multi-step conversion. I can convert first from days into hours, and then from hours into minutes. So let's set this up as if I was going to do two conversion steps. And I'm just going to fill in all these units just to sort of act as my skeleton for how I'm going to get from point A to point B. So first I want to cancel out of days. Canceling out of days, and the first place I want to get to is hours. So that's the unit I'm going to write on the top here, is hours. Now once those days cancel out, I'm left with hours, and so then I'm going to want to cancel out hours because I actually want to end up in minutes. So then I'll put minutes on the top. This is my skeleton. Then I just need to fill in my conversion factors. So if I'm looking at this one right here, how many hours are there in one day? Well, we know that there are 24 hours in one day. That's pretty straightforward. Then moving on to the next one, we know that there are 60 minutes in every 1 hour. So now I filled in all of my conversion factors. I simply need to multiply and divide. So in this one, we have multiple things in the numerator. We have to multiply 5 times 24 times 60. And we should get 7,200. We don't have to divide by anything because both of our denominators are 1. So there are 7,200 minutes in 5 days. Now if I want to round that to sig figs, it would be 7,000 minutes with sig figs. But that's pretty much unit conversion. We are going to get a lot more practice with dimensional analysis. I'm going to give you some homework to work on, and we are going to definitely talk about this more in class. I highly encourage you to come to my office hours if there's still something that you are confused with. But I hope you got these all right, and I will see you soon.